It's part of the, thank you, I'll say that again. Welcome everyone. This is data visualization for people in a hurry. It's part of the nwPlus workshop series. So today we're going to walk through your first data visualization in the R programming language. Again, and this is a bit more on the next slide. So the title comes from the Neil deGrasse Tyson book. If you haven't heard of it, it's not related at all, but I thought it was funny because the last name thing, my last name is DeMarco, his is deGrasse Tyson, so worked out pretty well. We won't be doing any astrophysics, so if that's what you came for, unfortunately, that is not the content of this workshop. This is focused on data visualization. So you can be totally new to programming, and this workshop will be fantastic for you. And if you have done some programming, but never like data science related things, would be really cool. If you've done like any of like Racket, CPSC 110, or if you've taken CPSC 103 and learned a bit of Python, that's excellent. If you've taken even more, perhaps like CPSC 210 and Java, or you're not a UBC student, you'll still get a ton from this workshop. So it's open to all kinds of backgrounds. This workshop is in part designed for a health science background. That's pretty loose. It's just based on the data set we're using. It should be like especially interested if you, I don't know, want to become a doctor or something, or maybe are a bio major, but that's by no means required. So you don't have to be a health science major. If you're a comp sci major, welcome. And this is part one of the workshop. So we're going to focus a lot on visualizing data. And in part two, we'll take it a step further and kind of go through a more complete data science pipeline and start talking about inference and more like cool and exciting things with data science, but today we'll focus on just visualizing data. A few notes I want to mention too right at the start. I know I sound a bit probably raspy and deep voice. I went through a bit of a cold. I'm like sort of on the come down now. I'm doing pretty good. I don't have COVID. I got tested, which is doubly good. If I sound a bit deep voice, hopefully it sounds nice. I'm doing my best Morgan Freeman impression today, I suppose, but yeah, that's how it'll be. Firstly, before I get any further, I'd love for our TAs to introduce themselves. So feel free, you can go left to right, sort of on the screen.
The screen says pretty much everything you need to know. Hi, I'm Jack. I'm currently director of HackCamp. You should sign up. Registrations are open right now, December 5th to 6th, hackcamp.nwPlus.io. That's my plug for today. I'm currently second year UBC Computer Science.
Hey everyone, I'm Allison. I'm one of the co-presidents at nwPlus. Also plug HackCamp. Really excited to see everyone there. I'll let Anne introduce herself.
My name is Anne. I'm also the other co-president at nwPlus. And I guess reiterating, plugging HackCamp, but also check out our last workshop series workshop as well, since you're here, and that's happening next week.
Sure. Thank you guys so much. So these are our TAs for the workshop. So if you ever have any questions, you can feel free to ping them or just send a message to either the Zoom chat or the Slack channel, which hopefully you folks are in. If one of the TAs could send the Slack link just in case somebody missed out on that to the Zoom chat, that'd be great. I realized I didn't include that in my list of helpful links. And then myself, so I'm not just this like strange man with a raspy voice. I'm Michael. I'm part of the external tools team at nwPlus. So basically we make the websites and I'm in second year computer science as well. So we have three main goals for today. One is to produce your first ever visualization of data using the R programming language. And if that's also your first few lines of code, that's very exciting. The second is to learn about how data science can enhance your workflow in non-programming courses. So for example, you're taking a bio course that is very lab-based, like how can you use that to enhance your workflow? And the third one is to explore data science at UBC. Hopefully it can generalize a little bit to other universities, but it is a little bit UBC focused. And especially in the context of hackathons as well, nwPlus, if you didn't know, is a hackathon club. And so we want to sort of explore what data science can mean in a hackathon setting. And then finally in the working world, what that can transition into. So these links are in the chat, but also they're on the slides in case you have access to the slides. You can see the slides at any point by going to this tiny URL at the bottom. And also don't feel the need to take notes or anything during the presentation. If you want to come back to these slides at any point, you can visit that link. They'll be there forever. So the data set is all linked there in the GitHub repository. There's also a website that's handy. So if you get lost in terms of the setup or anything, feel free to go there. But I'll touch more on that sort of once we get to the coding stage of the workshop after we're finished with the slides. So firstly, what is data science? Hopefully you recognize the meme, otherwise the slide is going to look a little bit strange. So just at the highest level, data science is, a lot of people call it sort of an interdisciplinary kind of science. It requires people to be a little bit of a software engineer, a little bit of a statistician, and then sometimes requires a bit of knowledge in a variety of different fields. Your core job is to process insights with data, but lots of jobs also sort of have that task inside of them, but are sort of more focused in their domain. So if, I don't know, maybe you're an astrophysicist, then you're working on, space data and you're trying to generate insights from that. Data scientists are tasked with doing that, but sort of in the most general sense, working on any kind of data set, but have a strong set of tools, both in terms of programming and in terms of their stats background, to be able to do all sorts of things. So they're very malleable, but it's a cool field that's growing. And it's definitely something that's more recent as well. It's sort of grown in recent years. So data science can be done with a few different programming languages. R is the one we'll be using today. I chose R for a few reasons. One of the biggest ones is that it's used at UBC quite extensively. So that made it a natural fit if you want to take this workshop and then perhaps take a course later on. This would be a great first step. But outside of that, R is also just used widely in the stats world and in the data science world. Another common one you'll see is Python, and Python is also a fantastic language to learn how to program. But Python workshops are, somewhat common. I thought R would be a little bit more unique, and hopefully you'll get sort of some new insight. Hopefully learn a new programming language today, or perhaps your first one. So yeah, we'll be working with the programming language R. Now, for some of you, when we're working through the visualizations, it might feel a little bit Excel-y to you. You might stop and ask yourself, hey, why couldn't I just do all of this in Excel? Especially if you're perhaps in solder or doing a business program, you might be an absolute pro at Excel or spreadsheets and can do a lot of that data processing within Excel. And often data scientists do use tools with spreadsheets or working with databases directly. But what R allows us to do, you'll especially see in part 2 of this workshop to come later on. But even today, you get to create really nice visualizations and get to do some really powerful things very quickly through the programming language. So that kind of fine-tuned detail you'll see as the visualizations become more and more complex will actually be really handy. So hopefully over the course of the workshop, I'll be able to prove to you that it's more than just a very fancy way of working with Excel. So you can see a few, I grabbed a few. There's a subreddit called Data is Beautiful. And they have a ton of fantastic charts and graphs. You can see all the very cool things people have done. And that's very frequently done in a programming language like R or Python. It just allows us a lot of, again, fine-tuned control. So you can see you could create a plot with all of the countries and then, in this top right here in Europe. And I could not imagine trying to do that in Excel. I'm sure there's a way, there's a will, there's a way typically, but R allows us this very powerful and fine-tuned control. So we'll walk through a lot of how that's possible today. Data science, it is a science, so it has a sort of standard scientific method process to it. Maybe not political science. If you are a poli-sci major, I apologize, but political science, is it a science? Who knows? It follows a fairly standard method to get results and then ensure they're reproducible. So this 4-part process starts by importing and exploring the data. So this could be from a variety of sources, a database in a far-off server, or perhaps a spreadsheet on your own computer. We then clean and wrangle the data. I'll touch more on this later. We typically create some sort of graph and test our hypothesis. We want to visualize our data and start to test out what we think might be true about our data, perhaps make some inference about it. And then finally, communicate our results, which is perhaps the most important step. If you're able to prove all sorts of things and you can understand it yourself, you have to be able to tell the world in some way. So a lot of data science is report writing and making things very clear. And a lot of it involves just sort of explanations and how do we take the stats and figures we're able to achieve and make them useful for people who don't know anything about stats, aren't data scientists themselves. Perhaps they're in a business context. It's like your CEO and you have to convince them to take one route or the other. So you want to make sure you're able to communicate your results really effectively. So today's challenge, we're going to be working with a fairly popular breast cancer tumor data set. And so this is a challenge trying to predict whether or not tumors are benign or malignant. If you've never heard benign, malignant before, I'm not a bio major either, so I had to look it up. Benign basically means that it's not cancerous, it's fine. And then malignant is it's indeed cancerous, so it's bad. So obviously, doctors will do and try to predict whether or not a tumor is benign or malignant. I said it too many times now. I get the swapped up so much. And so it's natural for data science to try to be applied to this context and try to make predictions of our own through code and through analyzing data sets. And so a company, hopefully you've heard of, called Google, has tried to take on this challenge and actually done very, very well. And so they made headlines a while ago. They published an article in Nature, which is a very famous science journal. And they were able to achieve some really dramatic results looking at the same, or not, maybe not exactly the same, but very similar data that you're going to be looking at today. And we're able to predict with quite good accuracy whether or not tumors were benign or malignant. Got to say that carefully. And so we'll be working on that exact same problem today. Hopefully it goes well. We'll have to see. So yeah, without further ado, I don't want to ramble too much, and I know you're all probably starting to drift off of your computers. So I want to get programming right from the hop. So this next little bit is going to be a little bit chaotic, but it's a good kind of chaos. So we're going to all have to get set up, but I promise it's not too bad. And the environment setup is really nice because it's all in your browser. So the first thing you'll want to do is find the Google Colab link. Now to ask a question, when I change tabs, can you guys see like that I switch tabs, or do I have to reshare? You're good? Okay, cool. So yeah, you want to click that first link in the Zoom chat, or it's not the first link, it's the fourth link that's labeled Colab. That'll take you to this. Just kidding, I don't have it pinned. It's Google Colab. So it'll take you to a screen that looks a little something like this. It feels strange binging something. I'm unironically using Microsoft Edge. It feels very strange. So yeah, should come to a screen a little bit something like this. And once you're there, there's just a few more steps to get set up. I'll give everyone a second to sort of get to that link, let their page load. So you'll see kind of across the top, we have 4 different options. We have examples, recent, Google Drive, GitHub, and upload. We're going to use the GitHub option. And then for that, we'll need the next link in the Zoom chat, which is the GitHub repo, or GH repo. I probably shouldn't have shortened it. So you want to paste that in to Colab and then hit search. And then it should populate, look a little bit something like this. Once you've gotten there, feel free to hit me with a yes in Zoom. If you don't know how to vote, you can go to the participants tab in the bottom of your Zoom window, and then there's like some voting options you get. So I see a few people flagging some yeses, looks good. Okay, they're rolling in. I assume that step is going good. Yeah, so just paste that link into the GitHub tab. And then this first one here, that's 0-dataviz blah, 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 blank is the one you want. And you'll just click that and then you'll be done. And that's basically it in terms of environment setup, which is pretty sweet. And then, yeah, we'll be off coding. So gotta wait for that to load. Again, so a few things I'll mention about the workshop now that we're sort of in the coding stage. So this workshop is designed to be a bit of a flipped workshop. So maybe you've heard of a flipped classroom before. If not, it's basically you're going to come to this workshop, and instead of me talking at you and like writing code at you, you're going to be doing a lot of the code writing. And then when you get stuck, you'll have a chance to ask questions to me and the other TAs here. So it does make things sometimes a bit more challenging, but hopefully a lot more engaging for you. Yeah, so the installs, it's not installing anything just yet. We will install dependencies in a second. I can do that while I'm talking. So you can see this first cell. This is the last setup cell, last setup step. This first cell has a bunch of lines commented out. We're going to just uncomment each of them. And I know it's going to be weird because you haven't even written a line of code yet and you're already sort of doing things, but just get rid of all these hashtags at the beginning of these lines, kind of like I am. And then you hit the play button to run the cell. And it'll say some warning message. I promise you the notebook is friendly. And this will take a little while, so I'll just sort of ramble on through it. So yeah, today, just one more person in the waiting room. it'll be a bit of a flip workshop, so you have a chance to work ahead. If at any point you're bored, you feel like things are going a bit too slow, or you're just tired of hearing my voice, you are totally welcome to just work ahead and sort of plunk along. There's sort of a bunch of questions that are explained, some like sample code for you to work from, and just like lots of documentation throughout the notebook, and also some like tests to help test out your code to make sure you're like on the right track. So if you're ever bored, just feel free to start kind of plunking along and work ahead. Otherwise, you can sort of stick with the rest of the gang, and we'll just work through the notebook together. So at times, I'll be talking through a few of the cells, showing you some example code and sort of walking you through what's going on. And then I'll pause and sort of let you guys try a little bit, try a few exercises, and then we'll all sort of come back together. Of course, at some points, you might find the exercise a bit tricky. Some of them, there's a few challenges in here too that are especially hard. So our TAs and myself are ready to help you. The best place to ask questions is in the Slack. So if you're not in there, now is a great time to join. But even if you are not in the Slack, you can hop in a breakout room with our TAs. So just shoot a message into the Zoom chat and mention that you'd like to be moved into a breakout room. And then one of our TAs will join you in a breakout room. And then you can share your screen and walk through one of the problems you're having. So libraries should finish being installed. It should be, you'll want to re-comment out those lines just so we don't install them again, because it takes a while and it's a bit annoying. Yeah, and then once you have those installed, you should be able to run the next step without a problem. So I'm just going to run through kind of what on earth you're looking at here. I know there's tons of like buttons, switches, text, everything is going on. So this is, what you're looking at is a notebook within Colab. And a lot of these things won't be relevant for us today, but each of these little chunks you have, that's sort of like a block of text, kind of like a paragraph in writing, you can think of as a cell. And then cells can each individually run. They're like all self-contained and run just a little bit of code at a time. You can create a new cell at any point by just hitting plus code, and then you'll have a new cell to work in if you'd like. But you won't have to do that at all today, or at least shouldn't, because all the cells you'll be working on are sort of already created throughout the notebook. You can make also text cells instead of code cells if you'd like. And yeah, there's one really handy trick in case your just notebook stops working for whatever reason, is you want to go up to this top menu, hit runtime, and then hit restart and run all. So sometimes when things aren't working, the cells have just been run in the wrong order or something has gone wrong. It can be helpful to sort of restart our notebook and then run all the cells from the top to where we're at. So you can do that by hitting restart and run all, and then it will just sort of get you back to where you were and hopefully clear out any bad things that were happening before. So that is about it for the environment setup. Hopefully everyone is good to go. Yeah, so now just sort of follow along with me for this first little bit as I sort of just run these intro cells. So you want to make sure you run and load in all of the libraries. And then this is what we covered already. So this was sort of our introduction to what data science is and a bit of the environment setup. And so now we're going to be moving on to learning a little bit about R and finally writing our first few lines of code. So we're going to start off by talking about wrangling data. But before I even define what wrangling is, first, I just want you to see some R code. So R can be tricky to read, especially if you've never seen a programming language before. So don't worry, this part will be a little bit tough, but just stick with us. There's some very basic syntax you need to know for today. So we'll learn how to assign a variable, how to make a method call, parameters, and then printing to your notebook cells output. So we'll learn each of these as we sort of go along, and this is all you have to know for today. So hopefully that's good news. It's only 4 things. The first one is variables. So variables hold on to some kind of data, and they work very similar to how they work in math. So you could say, okay, in math, I want x to be the value of 5, and then later on you could change it to 6, and then you could say x plus 2. So I know when letters started getting introduced to math when you were in grade school, it sucked and everyone was super disappointed, but it's still here in programming. So they will kind of like save our values at some point in the code, and the values are persistent from cell to cell. So if I in here run this cell, I can write a little math expression, but this 5 plus 9 won't be saved anywhere. But if I use this little arrow syntax, that means I'm saving the value 5 plus 4 into x. And then if I try to access x down here in the next cell, then the notebook will remember, and x has already been saved. And so if I do x, print x, or print x plus 2, I'll print that value. hopefully that makes sense. So that's variables. And you'll get a chance to sort of play around with that in just a second. And then before I get ahead of myself, there's also printing data. So very commonly, you'll want to sort of see what you're working with in R. When we have it saved as a variable, we kind of want to know what's in the variable a lot of the time. And so to print while working in these notebooks, we actually can just put the variable on its own line. So here you see I've sort of just left x by itself. I haven't done anything to it. I've just said it's an x, here it is. And then Jupyter interprets that as me wanting to print the value. So here you can see it prints the value of x, which is 9 right here. We can also explicitly write print and then these round brackets and then the variable name. So I can write print and then wrap x in these brackets, and then we'll also print it with this little bit of extra information, but frankly, for the purposes of this workshop, they're exactly the same. So I would just recommend sticking with throwing the variable on its own line, and then Jupyter will know, or sorry, Colab will know to print that out. So now this is the first time it's your turn. So you have a challenge in this cell. I want you to create a variable y that is equal to 7, and then create a variable z that is equal to the sum of x and y, and then finally print z. So I'll give you guys about a minute to work through this on your own, and then I'll walk through it. And then we also have these handy tests down here. So if you run this cell without having done the problem, you'll see that it complains. It says error and error. That means the test did not pass. If the tests do pass, it will simply print test passed. So you can know if you're on the right track by running this cell. And if you get the wrong answer, you can try, go back and change things again. So yeah, feel free to have a minute to work. And I think I'll stick with the like Zoom voting thing. So if you're finished, feel free to vote yes in Zoom so I can know when to sort of move on. And there's also 2 helpful things in Zoom with go slower and go faster. And so if I'm going way too fast and just like totally just zooming by, feel free to vote go slower so I'll know to slow down a little bit. And if I'm going too slow, feel free to vote go faster. So I'm going to start working through this one. If you didn't finish it, that's totally okay. And if you did finish already, you're also welcome to just keep sort of plugging along and working through. So this one asks us to create a variable y that is equal to 7. So again, we use the same arrow syntax as before. So we do this little fancy arrow pointing into y, and we set that to the value 7. One thing before I keep going, is the text on my screen too small, or is it like readable? I could zoom in, but if I don't need to. Anybody have any strong thoughts? I think it's good. It's good. Okay, cool. I'll leave it. Okay, so we created a variable y that is equal to 7, and then we're going to create a variable called z, same arrow syntax, and it's going to be equal to the sum of x and y, which is just x plus y. And you'll find that with R, anything you can do like in a normal like Google calculator where you type, times, a little asterisk, or a slash to divide, that will all just work in R as you want it to. So any of the mathy sort of things, they should just kind of work. So, and then finally we want to print z, and we can do that by just putting z on its own line. Nice and easy. So we run the cell and prints out 16, which looks good. And we run the test cell and boom, test pass. And I guess Google adds in those emojis. That's pretty cute. I didn't do that on purpose, so I love that. Okay, the next one asks you to change the value of x, and then does the value of z change? So as I said before, you can assign to a variable as many times as you like and change its value. So try that with x, and then see if the value of z changes by printing it. So for this one, I'll just walk through quick. If we change the value of x, did anybody, and feel free to type in the Zoom chat or unmute yourself if you're feeling bold. Did anybody find, did z change or not? What did you guys find? Z didn't change. Okay, sweet, good. I'm glad you found that. Otherwise, I would be very confused. So yeah, the value, if we assign, I don't know, x to anything, set it to 0, then if we print out z again, it doesn't change. And so this is a really subtle thing, but z isn't like permanently attached to x plus y. It's calculated right here, and then z is assigned to 16, but it's always at 16 until we change it again. So then if I wrote z is now x plus y, right, I should expect to see 7, because now I've done that computation again. So that line is fully evaluated. This x plus y happens, and then z is saved to that value. So hopefully that clarifies. I found that confusing when I first learned what a variable was. So hopefully that's helpful. And then we can run this test, and we should get another cool emoji, which is awesome. This next one asks you to do something a little bit trickier. So we want R to compute the square root of 4 and save it to a variable called a root. So I've given the hint, root shortens to square root. And if you've ever tried to Google a like square root value in like Google or something, you've like typed in like square root, you might have done this before and it'll work really similarly. So again, for this one, it's going to look pretty similar to how we did that print call from before, which I know I didn't speak a ton about, and we'll touch more on later when we get to functions. But the way this one goes, so we are assigning something to root. Now, if we know the value square root of 4, we could just say root equals 2, but that's less exciting. What we want to do instead is say root and set it to, now it shortens to square root. And then just like we did with print, we're going to wrap the value we want to pass in parentheses. So we're going to wrap the value 4 and then save that to root. And we can print it out just to check, and that's a good habit to get into. And I will run the cell. And we can see, cool, We got the value 2. So you can see, again, looks very similar to print. We name some function we'd like to do. And again, I'll touch more on this later, but just so you're getting exposed to sort of how the syntax looks. Then we write these curly brackets. I guess they're not curly, they're the round parentheses. And then we punch in the value. And another emoji. Okay, and then the last challenge in this set of challenges is we can also work with more than just numbers. So sometimes we also want to work with strings or like textual data. Why programmers chose the name strings, I have no idea, but it's just like characters in a row, sets of text. So in programming, we wrap strings with quotes. If you do these double quotes here or single quotes like this, either are fine in terms of R. Not every programming language thinks that, but R is chill with that. And so we signify this a value, not a variable name. So if I write hello here, this will actually cause my cell to fail because it thinks hello is a variable name. But if I write hello in quotes like this, then I'll be okay. And so you can do confusing things like set the variable x to the value x, and then you'll make your head explode. So feel free to create a variable x and assign it to the value hello, in quotes, importantly, and create a value y and assign it to world. So last but not least, in the variable section, hopefully my demo was good. So I'm first going to create a variable x called and assign it the value hello, and then y, and assign a world, and then I'm all done. I'll run that cell. It shouldn't print anything, but I've included this line down here, which will print the values together. So we got hello world, which if you've never done programming before, or you're new to computer science, hello world is a very common catchphrase, like the hello world program. It's like the first thing you do when you start any programming project. You're like, first, okay, I'm just going to make it say hello world, so I know that it's working. So boom, you've done it. You've made your hello world in R. So cross that hurdle, and then yeah, we'll get the test to pass. Woohoo, and a rainbow this time. Very cool. So Colab does this cool thing where it makes my notebook look a lot less intimidating by hiding all of these cells. But you can see here where it says 9 cells hidden or 5 cells hidden. All you have to do to sort of expand it is just click on it. And then boom, we will get to see all of the sort of things that are laying beneath. So the next concept is still a little mathy. We're going to talk about functions, which I've sort of alluded to before. It's very similar to y equals f of x. It's like a very similar concept. So we can map some sort of input and then get some sort of output value by doing some sort of computation. The general form of a function call, and what you'll see a lot in this workshop today, is we have sort of our result value, right, which is we now know is a variable, and then we're going to assign it to my function, whatever. This could be anything. It could be print, it could be paste, it could be a variety of things. And then we pass in what we sometimes call arguments, or sometimes parameters. There's a bunch of different names, kind of confusing. But yeah, these are just the things we're passing in as sort of the data for the function to operate on. These are our inputs. And then result is going to be our output value. So we pass these in sort of a comma separated list, and we wrap these in round brackets as well. So you can see kind of the analogy to y equals f of x. And then when we're working with R, we rarely create our own function, so don't worry about that. You can do it, and I've given a little example down here, but it's very rarely done, so I wouldn't worry about it too much. So we can run this test cell, and you can see, so I've defined a function here called Fahrenheit to Celsius, and then I've made a variable called how hot and converted the value 32 from Fahrenheit to Celsius using the same syntax I went over above. And we can see it's 0, so that's 0 degrees Celsius. So here I will let you work on these next 3 cells on your own. The first asks you to call the print function. The second asks you to call the help function, which will be very useful. And the third asks you to call the function select. So try each of those. Make sure to follow along carefully. Assign it to a variable when it asks you to. And this last test will help test this last cell here. So take a few minutes, work on that, and then I'll come back and go through all 3 of these. Something cool I can mention while you guys are working is because like Google Colab is kind of like the same as like Google Docs or something, you can actually like share your notebook. So if like a TA you're like trying to debug, you can like share it with someone else, which is pretty neat. You have to, before you do that, go File and save a copy in Drive, which I guess requires you having a Google account. So if you don't, that sucks. But you can then share your notebook with somebody else and they can edit kind of like a Google Doc, which I think is pretty cool. So feel free to give that a go if you're chilling out. I won't be doing that though. And again, the Zoom yes is always good to flag once you're finished. So don't be shy to use those Zoom phoning things. It's very helpful for me, or even the Zoom reactions or the chat, whatever works best for you. Just let me know how you're doing. Someone asked a really cool question that I can address. So somebody said, can you only use R on Jupyter or Google Colab, or can you use it in Visual Studio? I'm assuming you mean Visual Studio Code. Hopefully not Visual Studio. I'm not doing C programming here. You definitely can, and it's actually really cool. I think just yesterday, Visual Studio Code released a big update for their Visual Studio Code extension. And so it actually works really good now. I was playing around with it earlier today. Jupyter, I think, is the most like standard thing to work with notebooks in, but VS Code has added support for notebooks. I don't know if RStudio has support for notebooks. I've never actually tried, but RStudio is good for just writing straight up R code, which basically if you take all the code from the cells and just put it in one big long file, then that works too. And then you can use notebooks to do all sorts of things. You can add in markdown cells or text cells, as I mentioned before. So it's very cool. So yeah, if you like VS Code, then that works great. Yeah, I'm not sure either. I don't think it does. And to be honest, RStudio is thought it was hard to work with. So I usually just stick with Jupyter or something like that. Okay, I'm gonna walk through these three examples. So first one asks us to use the print function twice, first with 5 and then with a string. So just like before, we're going to call print. So now we know this is a function, and we're going to use brackets and get a 5, and then print, and pass in nwPlus. Easy as you like. And then the next one we call the help function. Now we haven't seen this function before, but we know roughly what a function call looks like. We know it's going to be help, and then our round brackets, and then something in the inside, maybe. And then it says with a single argument, just the text help, but not the string help. Okay, so that's kind of weird. So I'm gonna go like that. I guess just the text is okay. And I run it, and very cool. So I've never tried this in Colab before. This is funny. So this is how you access the documentation for R, is you use this help function, and then you can pass in almost anything. So I can pass in help print. Let's see what that does. Now, the problem I see, at least on my screen, is that it looks really bad. I don't know why, but it's just not totally reading it correctly. So you can roughly see kind of what's going on. Like I can see a bit of a description for print, but I'm getting all these weird, funny characters. So not as good as I was hoping it'd be, but that's, if you're ever stuck in the workshop and you're confused about sort of what a function does or like what parameters or arguments it takes, you can use this help function to help you out. So yeah. Hopefully you find that useful, even though Colab seems to sort of be butchering it. And then this last one asks us to call a function with 2 parameters, and we don't know what they are. Empty cars and MPG, okay. And then save it to a variable called mtmpg. Okay, so I'm gonna do mtmpg, and that's what I'm saving my value to. And then I call select, and do the round brackets again. And my first value is MT cars, and my second is MPG. And because I'm curious, I'm going to run that and print it. Let's have a look. Great. Okay, so I see some random info about cars. I'm not a huge car guy, but if you are, maybe there's something interesting in here you notice. So cool. Call the function 2 arguments, and you can functions can take as many or as few arguments as you like. They can also take no arguments. That's totally okay. And we're gonna little test and hopefully get an emoji, and we do. Awesome. Okay, so everybody, if you're caught up with me to this point, please give me a Zoom react or a vote in the poll. The poll is the best if you can figure out how. So I see one more yes trickle in. If you didn't catch it earlier, to access like the voting, you go to the bottom of kind of the Zoom window. If you have like grid view, it'll be like all the people, or like my face if you pinned me. And then at the bottom beneath me, there'll be this like button that says participants. Click on that, and then you're in the side window, and then you'll be able to vote. So please vote yes if you're with me where we are. You can also, while you're there, vote go slower or go faster if I'm going too slow or too fast. See about 9 yeses. That's pretty good. We have 23 humans in the call, so a few more wouldn't hurt. Okay, great. I see no no's, so I'm gonna assume people are doing good. Yeah, feel free though, if I'm going too fast, just shoot a message or flag in the Zoom poll. With that, I'm gonna carry on. I wonder if I can close these help windows. So this next one we're working on is with libraries. So you might have noticed here when we called select, I didn't define that function anywhere. Where did it come from? Who knows? So the way a lot of the time we're working we want to bring in extra functionality from somewhere else. And so the way we do that is by importing a library. So you can think of a library kind of like libraries in real life are access to knowledge and books. Libraries in code are access to functions and extra functionality. So we have things that are already built into R, like print and help, but sometimes we need to go further than that. For today's workshop, we actually just need one library called tidyverse, and that's the one you'll be using directly. So to import it, we use this library function that takes first we say library, and then we pass in the name of the library we want to import, not as a string, just as the text itself. And sometimes, as you saw at the very, very beginning of the workshop, if you remember, we have to install a library. And so the way we do that is with install.packages. And then here we pass in the string name of the library, which I know is kind of a subtle difference. So be careful to get that right. I still screwed up sometimes. So here is an example. Here I'm installing a package called dplyr and then loading it in with this library function. And I can run the cell. And I think it'll complain because, oh, okay, I guess it doesn't. So cool, it's going to install it anyway. That's great. And so here, this is just a short exercise to check that you can sort of got that part. So try installing the caret package and then importing it with the library function. Hopefully you had a chance to give that a go. Again, very similar to the code snippet I gave you above. So something that will be really handy throughout this workshop is copy and paste. So I'm going to copy and paste that code from above, change it to a package called caret. Again, here it's the string name, and then here it's just no quotes. Then I'm going to run that, and looking good. And that'll take a second. And then this test just checks that you imported it right. So you can give that a go if you'd like. Here, I just installed tidyverse again. It was installed at the top, but just for good measure, never hurts to install it more than once. And I guess this cell will have to wait for this cell to run. And then finally, once we've loaded in these libraries, we can read in our data set for the actual workshop, which is exciting. So I'm going to stuff that cell because it's okay. And yeah, so we already have tidyverse imported to the very top of the spreadsheet, or at the notebook of the spreadsheet. That's funny. And then, yeah, so let's run this cell. And so tidyverse gives us access, like I mentioned, libraries gives access to more functions. So one of those functions is especially handy. It's called read_CSV. So read, that's a good sign that we're reading in some kind of data. The CSV part means that we're reading in a CSV file. If you've heard of CSV files, that's excellent. If you haven't, no big deal. It's basically just a kind of stripped down spreadsheet. So it's a bunch of comma separated values that are sort of organized into rows and columns. So it's basically just a spreadsheet. So yeah, here we can pass in a URL. And so at this URL, there is a CSV file. And we're going to read it into a variable, which is great. We recognize this from before, hopefully. Then here, I'm just doing some extra code. Don't have to worry about this. I'm just assigning some column names. and then selecting those column names. So we can print out the data we've just imported here. Give you guys a second to do that really quick, but it should be basically instant at this point. You guys are already pros. So yeah, that's just doing cancer data, and then you can print it out. And just to check that everything is imported right, so boom, tons of data, very intimidating and long. So just to check that everything went okay, we can run this test and we get another emoji, awesome. So here I've given you a URL that has a data set that's contained, it's a CSV file. So here I'd like you to use the read CSV function to read in the value at this URL and then assign it to a variable called old faithful. Give that a go. Let me know how it goes. Definitely you have to apply a few concepts that you've learned so far today, so it could be a little bit tricky. All right, so I'll go ahead and walk through this one. If you didn't finish it, that's totally okay. Let's start by creating a variable called old faithful. And we know we're assigning something to it. And we also know kind of from the above example that we're going to call this read CSV function and we have to pass in a URL. Okay, so let's do that. I'm going to go read underscore CSV and use the round brackets again. And then we're passing a URL. Now here, I've given you a variable called URL very fittingly. So instead of copy and pasting this whole string in, I can just, my mouse is lagging. I am going to pass in the URL itself and then run that. And that looks good, but a good habit to get into is to always print out your data set. So I'm going to do that quick as well. And again, wow, tons of data, very long, very intimidating. Looks like everything is working good so far. And just in case, run it. And boom, another emoji. So that's a ton of data. We've managed to import our data set successfully. We've assigned some column names. Now we can really start working with it and start to get, down and dirty. So we need to understand the form the data is in before we get too much further. We can't really create a plot until we know what columns we're working with, what kind of form the data is in, what values are present, what their units are, things like that. So we want to explore the data a little bit first, and there's just a few functions in R to help us do that. So the first one, I give you an example, is called glimpse. Glimpse is a rather ugly way of looking at the data, but it does give you a kind of peek or glimpse into what you're working with. So you can see here are my columns, and those are all the values in each of the columns. So you have this diagnosis with some M's and radius with a ton of numbers and lots of numbers. So here, I give you three other ways of previewing the data, but I'm not going to tell you how to do them. I'm going to let you try it on your own first. So this first function you asked to use is called head. Next one you asked to use called tail. And then I ask you again to try using head a different way. So give these three challenges a try. I'll give you a couple minutes to work on those, and then we'll come back together and walk through them. All right. Hopefully you had a chance to give those a shot. I'm just going to walk through them really quick. So the first one is called head. And so what head takes is a data frame is what you'll hear data scientists call it a lot. Basically, that's just the very fancy souped up variable that contains all of our data. So it's kind of what we read into. So here, when we read into Old Faithful, for example, we read in and get a data frame. That's what Old Faithful becomes. So let's grab cancer data from before. And here we're going to pass that data frame into the head function and try running that. And so what head does is it gives us a slice of the data from the top. So like the head of the data, and it grabs us 6 rows by default. If we do the same thing with tail, we can punch in cancer data again. And anybody have a guess as to what tail does differently? Feel free to send it to the chat if you have one. Exactly. Yeah. Carlos totally got it right. So it shows the data starting from the bottom of the data frame, and then we go up. And so we get the bottom 6 rows here. And then here I ask you to call head, and we're calling it on cancer data again. But now we pass in a second value, so like a number. So I'm going to try just number 1 and try running that. Let's see what that does. Here I get 1 row. Okay, interesting. Let's try doing it with 10. Okay, now I get a lot more. It looks like I get 10 rows. So does anybody have a guess as to what the second parameter gives us? The number of rows, exactly. So guys are on a roll. That just specifies the number of rows, which can be useful sometimes. If we want to grab, say, just the top row, we can do head 1, and then we'll just grab that. So occasionally, or the bottom row, tail 1, can be very useful. And that's just a little bit more practice with function calls and getting used to that syntax. Exactly, the default equals 6. Really good, you guys. Okay, so cool. Now we're going to move on to filtering data. So in this next section, we're going to try to narrow down the amount of data we're working with. Here we have a ton of data related to tumors, whether or not they're cancerous or not, we don't know. And sometimes we might want to limit the scope of our analysis. What if we want only people with ID numbers that have the last digit as being equal to 1? Or what if we want tumors that have a radius greater than 20? Or something, right? We want to be able to limit our data down in some way. So we're going to work with the filter function to do that. Now, before I get on to talk about the filter function, I first have to explain to you a new kind of variable, or value, I should say. So before we work with numbers, and we also work with strings, which are like text data. Now we're going to work with Boolean values, which are like true or false. If you've never heard the word Boolean before, don't worry about it. If you have, probably taken 103 or 110. So they're just true or false. They're one of 2 different things, and they work exactly like you want them to. They're very similar to, you know, how you can say true and false, true or false, and they will give you the outputs you want. So here in R, false and true must be fully capitalized. We have a few comparison operators, is the fancy way of putting it, for doing sort of the like true equals true, false equals true, things like that. So here we're going to compare the values of 3 and 6. So before, remember we were assigning with the arrow syntax. So we said x is going to be equal to a value, say, of 3. Here we're not saying assign 3 plus 3 to 6, set like 6 equal to this. We're comparing them. We're saying, is 3 the same as 6? If this is true, it prints out true, and if it's false, it prints out false. This is how we do not equal to, this is how we do greater than, and this is how we do less than. So again, probably recognize a lot of this from math. Feels a little mathy, you know, it's how it is sometimes. So yeah, we can run this cell, and it will print out all of those values. So we can see, just like we would expect, 3 plus 3 equals 6 is going to give us a value of true, whereas 3 plus 3 not equal to 6 is a value of false. And I know it take a sec to sort of wrap your head around, but feel free to take a moment on that. And then once you sort of feel you have that under control, give these next batch of problems a try. This one is definitely a bit of a challenge where it's kind of this longer write-up and I have these operators. So if this one you like, or like, I don't know what's going on here, feel free to just skip it. It's not super important. But yeah, give these first two a go, and then you can skip that one and try working with filter. And so I'll give you about a minute to do these, and then I'll bring everyone back. All right, I'm going to walk through this first one just because something I want to reiterate. So it just asks us to print the value of 5 equals 4. So again, that's going to compare 5 and 4. And if they are equal, it'll return true. And then do 5 equals 5. And print those values. And here, I'm just asking you to think again. Okay, so the values of true and false are in all caps. And that's a bit weird. You usually don't see that in some programming languages, but in R, that's something that's a little bit odd and something to take careful note of, is that whenever you do type false or true explicitly, that they have to be in all caps. Here, something a little bit more abstract, I guess. Print the result of whether or not negative 100 is greater than 0, and save that to a variable called isColder. Okay, so first thing to do, make a variable called isColder. Now let's think about what we're trying to compare. So negative 100, okay, we can translate that into code, negative 100 by typing the actual number. And then we want to say, is that greater? So is that greater than 0? And then we print that value out. And it should, it was false. And it does. And we expect the value to be false, and it's false, and that's good. This is a pretty long example. If you didn't get to it, that's totally okay. I'm going to walk through it right now. So it's a really abstract problem. It says the variable weekday is true if it's a weekday, and the variable vacation is true if we are on vacation. We sleep in if it's not a weekday or we're on vacation. Set sleep in to its correct value. So, I mean, if you're me, you're reading this problem and you're saying sleep in is always true because, you know, school's online. It doesn't really matter. But if you're following the problem, then I suppose you have to assign to the correct values. So we have to first check weekday and vacation. So let's just flick down to the bottom, and weekday and vacation are given some values here. So, okay, let's first do it just thinking about the problem at hand. So we sleep in if it is not a weekday. Okay, so here it says weekday is true. So it is a weekday. So that's not very helpful. Or if we're on vacation. So vacation is false. So we're also not on vacation. Therefore, since it is a weekday and we're not on vacation, then sleep in is false. Okay. We set it to that value and run that cell. And then run this. And it should pass. Awesome. Now there's a fancier way to go about this problem, and that's what all this sort of middle stuff is about, using what are called logical operators. So we can compare, just like we can compare numbers, say like is 5 greater than 3, we can also compare Boolean values, true or false. And we do this in English all the time. Right here, I say we sleep in if it is not a weekday or we're on vacation. In code, this translates much the same way. So here we have 3 different logical operators. And is like both things must be true for it to return true. So true and false is going to return false, since not both things are true. And true, okay, that can return true. We also have or, which is going to be either or are true or both are true. Those are all fine. But if both are false, then we return false. And I'm saying true and false so many times, so I know it might be easy to get a little lost, but hopefully these are sort of making sense. So here, true or false. Well, one of them is true, so we can spit out true. Here, false or false, this will return false. And then finally, we have not, and not just flips the value. So not false is true, and not true is false. So if we want to solve this problem for extra brownie points, we can do it with logical operators. So we can say, okay, sleep in is going to be true if not a weekday, so not weekday, or with the double vertical lines, we're on vacation or vacation. And that should also give us the right value. So what we could do then is change these values to say weekday is now false. And also print sleep in on the line below. And cool, sleep in now is true. Change one of the values. We're not on a weekday, it's the weekend, so we can sleep in. So hopefully that makes sense. If it didn't, don't worry about it too much, but that's just a little sort of glimpse further into the R programming language and some like cool things you can do as you get further along. So now that we know what Boolean values are, we can start to work with filters. So filter is a function that takes 2 arguments, a data frame, which we covered before, and then an expression that returns either true or false based on a column name or column names. So we have to be, there's a few things going on here that I want to talk about. So the first thing I want to do before we get to all this filtering nonsense is just print our data frame. So, and it's going to print the filter data below, and that's okay. I'll talk about that in a sec. So in this top data frame, you can see we have our column names up here. These we'll use a lot in some of the R functions we work with today. And so we can use these to perform all kinds of operations. And we're definitely going to use them when we talk about filter, because that's how we like set up our expression. So here, this part of it, you can see radius matches radius exactly. It's a column name. But I couldn't type, for example, if I wanted to filter cancer data, and then pass in, say, look at this one here, concave points. So if I want to do concave points greater than, let's say, I don't know, 0.1. This won't work because of the space, which can be a bit confusing at first. I also cannot do concave points without, like I can't do it like this. I can't have a random capital letter in there. It has to match exactly how it looks in the data frame itself. And so when you're trying to filter and the filter isn't working, or you're trying anything where you're like thinking you're working with column names, make sure to check your data frame first, make sure your column names match exactly, and then try to, fix something else. So yeah, that's a bit about filter. And you can see here, so if we look at this top data frame, we have sort of all of our data, all kinds of radiuses, 11, 20, 19, 20. And then here we can see that we've filtered. And so we've removed a bunch of rows from our data frame, and we are left with only rows where the radius is greater than 20. So filter throws away all of the rows where this expression returns false and keeps all the ones where it returns true. And this can be a bit tricky at first, but you'll have to practice with it. So hopefully it'll make more sense once you get to try running these on your own. And again, remember that copy paste is your friend. So yeah, if you're ever stuck, try taking this, copy it, and then just tweak things about it until you get it to print out what you want. So this first one asks you to filter all the rows where the diagnosis equals B. B stands for benign in our data set, and save this to a value called benign rows. And then it asks you to do the same thing for malignant rows. So give this a go. It is tricky, so if you get stuck, don't be afraid to message in the Zoom chat or on Slack. I'll be watching closely. Yeah, give both these problems a go. There's also tests included, so you can see if you did them right. And then I'll walk through all of them once you're finished. So good luck with that. Hopefully you had a chance to give at least one of those a go. They're quite similar, so hopefully if you got the first one, you can definitely do the second one. The first one, it's asking you to filter all the rows where diagnosis is B. And so that's grabbing all of the benign rows. So we're going to make a variable called benign rows, do the arrow syntax again, and then do filter. Again, our original data frame is called cancer underscore data. And then it actually gives us the expression here, which hopefully you found useful. So I can copy and paste this exactly as it is. Oops. I don't know what that did. Okay, and then I'll paste that in, and that will do the filtering. So you can see this is our condition. So it's only where this line returns true, and this is the data frame we're working with. So let's also print that out, because that's a good habit to get into to make sure we're on the right track. And awesome. Looks like it worked. These are all B's. That's good news. Sweet. And then we do the same thing for malignant rows. If you took a look, if you were stuck on this one, the best thing to do is to go back and look at the data frame. And here you see, aside from B's, we also have M's, very fitting, M for malignant. So that's what we need to filter for. So it's our code is gonna look really similar to how it did last time, except now we're working with malignant rows. And we're doing a filter on our original data again. And now our condition is where diagnosis equals M. And I'll save printing that one just so That wasn't too long. And we'll run this test, and awesome, it passed. So here I ask you to use a new function called nrow. So nrow takes in a data frame as the argument, and then returns that as a number. So if I do nrow on Old Faithful and let that print out, see it spits out 272, which is the number of rows in that data frame. So your challenge is to use nrow to find the number of rows in both the benign rows data frame and the malignant underscore rows data frame. And then after that, compute the total number of rows in the data set. So give that a go. If you finish those, there's also a good challenge below here where you calculate the percentage of the original data that is malignant tumors and the percentage of the original data that is benign tumors. So give that a go. You can go all the way up to 2.4. There's also a bit of a thinking question here that I'll cover. So yeah, work through all of these all the way up to 2.4. I'll give you, again, a couple of minutes to do that. And then, yeah, we'll come back and I'll walk through those. All right, so I'm going to start working through the next batch of exercises. If you're midway through one of the problems, feel free to just sort of like tune me out and you can keep plunking away. Otherwise, yeah, if you're a bit stuck, hopefully I can help get you a little bit unstuck. So the first one, we're just using nrow in about the exact same way I did here. So let's start with num malignant. And again, we're just counting the number of rows in the data frame. So let's do this with malignant rows. And then the exact same thing with num benign. So again, copy and paste is your friend. It will save you so much time, effort, and energy. Boom. So we have both those values. And then I'll just do this one immediately. So it asks us to give you the total number of rows, which given we filtered on the benign tumors and the malignant tumors, and those are all the kinds of tumors there are, then we should just be able to add these two values. And that will be the total number of rows in the data frame. There's other ways you could have done this problem as well. You could have done nrow on the original data frame. That would have worked totally fine. This is more what I was going for. So run that and run that. And we should see that this test passes, and it does, which is awesome. So now the challenge problem, I'll walk through just a little bit to get you guys going. So this is really just a math problem, which I know it seems like I keep talking about math today. Maybe that's what data science just really is. So what you want to do is find the percentage benign and the percentage malignant in the data set. So I'll just do percentage benign just to save us a little bit of time, but it's exactly, there's kind of the opposite for malignant. So we'll take num benign, we'll divide it by total. That's going to be the fraction of benign tumors that are in the data set. And then we'll multiply by 100 since it's a percentage. And if we just leave that on some line and don't save it to a variable, it should print. And we get about 60% of the data as benign. And then so we can guess that about 40% is malignant. So here it asks you to think about, okay, so we have about 40% of the data as malignant and 60% is benign. Imagine we had a new piece of tumor data that had all the same columns that we have here. If we wanted to make a prediction whether or not that new tumor was malignant or benign, what implications would that imbalance have? If anybody has a guess, feel free to send it to the chat. Otherwise, I can fill you in. This is a huge foreshadow. This is like what we'll come back to right at the very tail end of the workshop. But I figured I'd give you guys a little sneak peek. So if we have imbalanced data, more of one kind than the other, what effect could that have? That's really good. You're definitely on the right track. I see Ahmed's got some thoughts. So it's kind of like a starting probability for the algorithm to make predictions. It's like the data it's working from. So what Ahmed's sort of getting at is if we use this data to train our model, imagine we had some sort of machine learning model, and it's a like very fancy function that takes in data about a new tumor and outputs what it thinks it is, malignant or benign. So Ahmed's totally right. Like these are sort of our starting probabilities if we use this entire data set as our training data. And so it would be more sort of biased towards one than the other, right? If it had more examples of, I guess in this case, it's benign tumors, then it's going to probably be more likely to predict whether, given a new tumor, it's going to be more likely to predict that it is benign. And if that didn't totally make sense, don't worry about it. We'll touch more on it right at the tail end of the workshop, but that's totally on the right track. +1 brownie points, Ahmed. That's great stuff. Yeah, that's the core idea, is that what data we train our model on will influence what it's able to do later on. So balance is a really important thing. Okay, so that was filtering. Now we're going to do selecting data. It's a lot shorter since it's really similar to filter. Instead of filtering and getting rid of some rows from our data frame, now we're going to be choosing columns in our data frame. So the function here is called select. Its first parameter, just like filter, must be the data set. And then every parameter after is a column we want to keep. And we can put in as many columns as we'd like. So for example, we have some new data frame that's our selected columns. We call select, pass in our original data, and then all of the columns sort of as comma separated values we'd like to keep. So here I show you a little example. We say cancer only IDs. So the cancer data frame with only the IDs column there is going to be equal to select of cancer data and the ID column. You run that and boom, we just get the single column. So hopefully this one isn't, now that you've seen filter, hopefully this one is a little bit easier. And so I give you a couple challenges. The first is to select these given columns. Ooh, there's a little typo here. I changed the column name. So this one shouldn't say radius. It shouldn't say radius mean, it should say radius. And this one should say smoothness. Sorry about that. So select only the diagnosis, radius, and smoothness columns from the original cancer data and save that to a variable. And here we introduce a little bit of new syntax for selecting columns. I'll give you a chance to read through that. And then it asks you to select every column except the diagnosis column and the ID column. So give that a go. I'll give you a couple minutes to do that, and then we'll come back. All right, so hopefully you had a chance to work through those. Again, should feel really similar to how you do filter. So I'm just going to use really quick. This one, we're doing cancer select is going to be equal to select our cancer data, and we're doing diagnosis, radius, and smoothness. Excuse me. Okay, so that's that, and we'll let the test check our results, and it passed. That's awesome. Here I introduce sort of the minus notation for selecting everything except those ones. So we can do cancer select. Oh, this one's called anonymous data. Oops. Okay, let me grab that. I don't want to try typing that. So we can do anonymous data is going to be equal to select. We again pass in cancer data, and then we want to just remove a few columns. So the only columns we want to remove are diagnosis and ID. So we do minus diagnosis and minus ID. And I'll print that one out so you guys can see what that looks like. See here, we removed the diagnosis and the ID. So we don't know anything about which tumor is which. So this is like totally anonymous data. Great. So the TLDR of that section is with selecting, filtering, and some more functions that I didn't go over, but is sort of buried in this 2.x challenge section. You can do this process known as wrangling, which is a super important part of data science because we really want to work with clean, or sometimes called tidy, data. That's really important for making certain functions work properly and making sure our analysis can be done smoothly without too many hiccups. So feel free on your own time after the workshop or later on to have a go at 2.x challenge. If you've been working ahead and got to these, that's awesome. That includes some more wrangling techniques and some like extra wrangling related challenges. But we're going to move on to section 3, which is the first visualization. I'm going to skip this first section. It's basically about, instead of creating visualizations, it's how to sort of numerically summarize our data. So a visualization is great for producing sort of a visual, like, okay, this is what our data looks like. So you can sort of just see it all at once. But sometimes you want to compute things like the mean or the average or the standard deviation, the median, the mode. This section sort of covers that. It's not super exciting, so I'm just going to leave it since we're a little short on time, but feel free to give that a go later on. So instead, we're going to jump right into ggplot. So ggplot is the very souped up, very fancy function in R that we use to do all kinds of different visualizations or plots, hence the name ggplot. It's super powerful, and you can create tons of different charts with it. The only way to master it is to just sort of try out different things and get comfortable with the syntax. It looks a little strange. There's a lot going on. Some of you probably skim down to the code cell below and are like, oh my goodness, what's going on? Don't worry, I'll talk about all of it. So here, let's just start by running some code, and then I'll break it down. So this is our first ever plot in R. So hopefully that's exciting. Now we finally, like the crux of the workshop, created our first visualization. You can see we have some axes labels. We're producing a scatter plot. If you're taking a stat course, you might have seen it before. If you haven't, no worries. It's just each dot represents some X, Y value of, I guess it's radius and smoothness here. And I know those axes labels are super tiny. We'll fix that in just a little bit. Yeah, so that's all the points on this graph represent that. We're missing a title. We're missing some other things we'd probably like, but you know, this is a start. So it looks scary, so let's break it down. So firstly, we should recognize ggplot as a function. We call it, and then it has these nice brackets around it. Then it takes a series of arguments. The first is still a data frame, just like before. The second, AES, it's short for aesthetic specifications. This, for our purposes of this workshop, it's just the X value and the Y value. So you write AES, and then you say X equals the column name that you'd like to be the X, and the Y is going to be the column name you'd like to be the Y value. So that's all that's happening in this first line is we're just calling ggplot with the data frame, and then we're setting the X and Y values. So hopefully like that isn't too scary just yet. you can feel free to ignore what's going on below with this like plus symbol. And then we have this geom_point thing. Just ignore that for now. We'll touch on that in just a little bit. Let's first try changing what we're using for the X and Y values. So here, again, I made a little typo. I changed the column names. So this should be perimeter and this should be area. Try by copy and paste, grab this one and then bring it in here. You'll have to change the data frame and the X and Y columns. Try producing a new plot. Give that a go, and I'll give you guys about a minute to do that. It'll be a little bit tricky, but give it a shot. All right, so I'm going to go over that one quick. So we're going to use this code from above. Again, this is good practice. If you have code that works and you're trying to do something new, don't reinvent the wheel. Let's paste in, and we need to rename our plot. So we can call this one geometry plot, since we're working with area and perimeter. And we know we're going to print it out in the end. Okay, so we need to change our data frame, because if you remember from way earlier, cancer select limited the number of columns in the data frame. We like took out a bunch of things. So now we want to go cancer data, and this just has all the columns, which is great. And then we set the X value to perimeter and the Y to area. Sweet. Okay, and we don't change anything else. It should just work. So let's run that and see what happens. Okay, we get a much different looking plot. Makes sense, right? Because area is loosely, directly related to perimeter. So that makes a whole lot of sense that these two variables show much more relationship than this one above. We kind of have the values much more spread out up here. And boom, there you go. You've done your first visualization. Here, I ask you to, from the last cell, and we can do this one together. It's not too crazy. Let's change geom_point to geom_violin. And we get a whole new kind of plot. So if you've never seen a plot like this before, it's a violin plot. What it is, feel free to Google. It's beyond the scope of this workshop. You can see changing from geom_point, where we had a scatter plot, to geom_violin gave us the violin plot. So there must be something going on here, and it probably has something to do with this plus symbol. So let's talk about that. A core part of ggplot is adding layers. So that's, you can kind of think of it like layers on a cake, or sort of stacking things up. So first, our base call is always ggplot, and we do, we set the data frame, we set the X and Y value. Then when we want to keep adding things to our plot, we very fittingly use the plus symbol. And one thing that's important to specify is the geom_something function, which gives us the kind of plot we're working with. So geom bar is a bar graph, and geom point is a scatter plot, geom violin plot, and there's many more. I actually gave you a link to them right here. So feel free, if you're curious, to look through a bunch of those and try messing around. It can be kind of fun. We here add a bunch more layers. So we say plus the X lab, whatever that is, we'll come to that in a sec. The Y lab, we add another geom, we do a geom smooth, and then we also add a theme thing. So let's run that cell and see what it gives us. So here, graph is looking quite a bit better. We've come quite far from where we started. So we have bigger axes labels, so the same as before. We've added this blue line, which is a line of best fit. And yeah, so things are looking a lot better. So what's going on here, I'll sort of break it down. X lab is X label, so like your X axis label, and we can pass in a string that is what we're going to call it. Do the same thing for Y lab, Y label. GM smooth is just a linear regression, like sort of line of best fit. Again, a bit beyond the scope of this, but it's just to show you that you can add multiple GMs together and combine them in all sorts of crazy ways to do cool things. And then theme changes sort of like the visual identity of our plot. So here we say theme text equals element text size equals 30. Looks really complicated, but what it does is change the font size of both of our labels. So with layers, we can start to make our plots better and better and better and do cooler and cooler things. So here I give you 2 challenges, and these are going to be tricky, so don't be shy, ask questions. Zoom chat's been a little quiet. Here I want you to change the above piece of code to make the font size now 60. And then in this one, I ask you to add a new point to the plot you just created. And this is tricky. So again, don't be shy. Feel free to ask questions. I also link here the documentation for gm_point. Google is your friend here. If you're stuck, don't be shy. Google things, ask us. So yeah, add a new point to the plot you created. And yeah, and then do some things that set its color to be red and make its size and stroke value to 5. So try both of those. Again, they'll be hard, but we're here to help you. So good luck, and I'll come back in about 3-4 minutes. I'm going to start to work through the first exercise, just so we have enough time to sort of like wrap up and do our like closing discussion. So the first plot asks you to add a new layer that changes the theme. So what we could do is let's take this original plot and save it to a value. And let's call this basic plot. You could also use a basic plot from above, but this will look a little bit better. And now what we can do is we can change things about basic plot by adding new layers. So we can do basic plot and then just use plus, and we want to print it out directly, so I won't bother saving it to a variable. And let's, instead of doing this one, let's do a size equals 60. And I'm going to get rid of the original theme. Okay, great. So this will print out, again, with the rather large axes labels, our plot from before, which is cool. And so hopefully that gives you a good sense of like kind of how this layer thing works. We can just plus any plot we've already made and keep adding new things. This one is really tricky. I'm not even sure I remember the syntax for it, but we'll see. So basic plot, now we want to add a new point on our graph. So the way we add a point is with geom point. And hopefully you're able to see in the documentation before we did geom point with no arguments, and that just defaults it for every value in the data frame. Here we want to add a specific new point. The way we do that is by passing an x and y value. So we need to specify it's x and y. For radius, it looks like a good value would be like 15. And then for smoothness, like 0.1, just so it's right in the middle. We also need to specify its color. And the way you do that is by saying color equals and then a string value, and we can do red. And we can make it big by setting size equals 5 and stroke equals 5. It should be very large, hopefully, if I've done it right. And I don't want to do an arrow. That was my bad. I want to do a plus. And let's see what that looks like with the new layer. If I didn't make any syntax errors, which I did. So, oh, yeah. So this first argument can't be just x and y. I think it has to be AES, x equals, and y equals. And if that's not right, I'm going to look at the solution. So that's, I think, what it's supposed to take in. That's the first thing. Oh, I probably can do x and y. Oh, I guess x and y worked. Okay, good. I'm surprised. So here you can see I threw an x and y on there. And the theme is gone from before. So I no longer have the 60-60. But now I have a new point with an x value and a y value, and I've made it enormous. So hopefully that was cool. Now you kind of are very familiar with how to work with ggplot. In this next section, we get a bit fancier. So we do things like adding a title to the plot and coloring our points. I ask you to create a bar chart and then create some other kind of plot. And unfortunately, because we're a bit short on time, I'm not going to have time within the workshop to do this. But feel free to either do that like after this workshop, tomorrow, a week from now. These exercises are really good for getting you more comfortable. And there's some really cool ones in the challenges too. It goes so far. I think the very last one is to create a 3D plot. So you can give that a go if you're feeling really keen. And then part 2, we'll start talking more about inference. So stay tuned for that. Make sure to head out to Hack Camp, where there'll be more workshops. You get to learn more things kind of like this. Before I totally close out, there's a few things I want to say. The first I can show you is from the solution file. Oh boy, it's long. Let's see if I'm going to make it there. So I want to run off. Maybe I'll let that run for a second. I'm asking a lot from Google Colab today. Maybe their servers went up for it. I was going to show you the colored plot. You can do that on your own. Basically, the next section, we were going to color the points. And if they were a certain, either like benign or malignant, we would color them blue. And if they were the other one, we'd color them a different color, say red. And that is cool. Then you get a kind of a better sense. Something you'll definitely want to do right now while you're here, you made it to the bitter end, is you could hit File and then go save a copy in Drive. And that way you have your work, you can come back to it later on. And I'm pretty sure can open it straight from Google Drive. Otherwise, you can go in Colab, and on that original screen where we sort of like opened from GitHub, instead you just open it from Drive. And if you have a Google account, this should be super easy. So yeah, feel free to save it to your Drive, which is really awesome. Huge benefit of using Google Colab. So yeah, do that, file, and then go save to Drive. I did have a few closing slides, nothing too wild. I did want to give credit. There's a few really excellent resources. Oh, thank you, Anne. I will shut that out. So in making this workshop, I used a really cool workshop from Harvard. There's this cool website called Learn X in Y Minutes. That was great for reviewing the syntax. Feel free to give that a Google. And also, I am a TA for UBC's Intro Data Science course, Data Science 100. And they have a course textbook that has been written by UBC instructors. It is absolutely excellent. So feel free to look it up. It's on GitHub, totally available to the whole world. And take that course if you're a UBC student. If you're not, there's tons of ways to learn data science for free online. So feel free to poke around, look stuff up, get comfortable with R, Python, and who knows, maybe you can be a data scientist one day. That's about everything. There is one thing. So in the chat, you'll see there's a feedback form. Please fill that out. That would be super helpful for me if we were to run this workshop again. The feedback is absolutely essential. So please fill that out really quick. And yeah, again, just attend Hack Camp. I gotta plug. It's gonna be awesome. It's happening this December. It's an invalid link. That sucks. Okay. What? Let's see. Oh, invalid dynamic link. That is super weird. Yeah. That might be, Allison, that might be like the forums like share link. Work. Oh God. That's funny. It looks like Google crashed. Maybe I'm wrong, but it kind of looks like Google crashed. Okay, second one worked. Sweet. Yeah, so fill out that form. That would be super, super helpful. Thank you guys all so much for coming. Stuck it through. Did the full 2 hours. Hopefully you feel better about programming in R and more comfortable. Now you know a little bit about data science. Hopefully that's pretty cool. So yeah. Thanks for coming. It's weird because I just sort of talking to an empty room. There's no like applause or anything. It's just sort of quiet. But I hope you